Hi, my name is Michael at UCLA's VAST Lab, and I'll be presenting our project, a complete SAT solver on a U55 FPGA. Boolean satisfiability is the first NP-hard problem. This means that the worst case to solving a SAT instance is to try all 2 to the n possibilities. SAT solving is not computationally intensive as there are no math operations involved. Instead, it is more like doing database lookup. An assignment is made and clauses that are affected are checked whether they become SAT or unsat. The first algorithm for SAT solving is the DPL algorithm. However, there have been many improvements added on top of DPL, such as clause learning. SAT solving is used in many domain-specific applications. Applications such as AI, circuit verification, and planning can describe the problem as logical expressions. The widely used form used by SAT solvers are written in the conjunctive normal form. FPGAs are well positioned for SAT acceleration. SAT solving involves many different heuristics, and these heuristics are interchangeable. On the right is a description of the solving algorithm. Highlighted in red are the heuristics that can be swapped with a different one. Development of new heuristics are relatively slow as it can take up to a few years for major advancements. All the while, HLS tools have greatly reduced turnaround time, so implementing these heuristics are relatively quick. This is our implementation of a complete SAT solver on a U55C FPGA. For it to be competitive, it needs to be able to support instances of variable clause length, replace CPU-friendly with FPGA-friendly operations, and parallelize wherever possible. We compare our results against Minisat and KitSat, both state-of-the-art and widely used CPU SAT solvers. On average, our design is 17.9 times faster than Minisat and 2.7 times faster than KitSat. For our design, propagation takes the most time, and this is due to the bottlenecking when propagating log variables at the same time. The instances used are considered small due to our design utilizing only on-chip memory. This is because off-chip memory has a high latency access and SAT solving has a random but small memory access pattern. Here's a quick demonstration of our demo. First, we need to enable host memory support, then run the provide test script. As you can see, our FPGA is attempting to solve all the instances in the benchmark. The results are saved into a CSV file where it contains some runtime information.